Well, for the sake of questions, we first draw a diagram, and the input is the signal and the noise, and it goes through a filter, and then we get the output. YFT is the means the signals that which goes through the filter, and the YNT means that the noise which goes through the filter. And according to the definition of SNR, we know that the square of SNR should equals with this part, and the above this part means the power of the signal, and this part the above the below one means the power of the noise. And for this one, we know that this part equals the autocorrelation of yn, which when tau equals 0, so that we can write this part into like this. And also we have, according to the inverse transform, we know that the autocorrelation of yn should equals this one. And when tau equals 0, so the e power of j omega tau should equals with 1, so that this part equals this one. And we know that this part should equals this one. And for the above part, also we can use the inverse transform, so that we can get the square of y of t should equals this one. And here we should according to the Scratch inequality, and we know that this one is this or equal with the product of these two parts. And because this part is always less or equal with 1, so we can see that this part is less or equal with the product of these two parts. And how do we get this inequality? And I can prove it briefly. And we know that this part is also, this function is also greater or equal with 0, so that we will have this one, and we change it a little bit. So we can rewrite this function into this one, and we can see it as a function of z, and which means that we should find the condition which satisfies that this equation is always greater or equal with 0, no matter what the value z is, so that the delta, which equals b squared minus 4 times of ac, should always less or equal with 0, and it can satisfy that all z satisfies this function, and in this function